All right, last time we were talking about the array stack, of course. And here we go. We were writing this code. We talked about having two constructors. I quickly did this constructor chaining thing where this right here, it's just calling this constructor, right? With the capacity set to whatever the default capacity is, which is kind of neat. We talked about push, but of course we might run out of space, so we need our expand capacity. This looks a heck of a lot like every other expand capacity we've written so far. We've got our pop, our peak, but that's where we left it. Ideally, we're going to want a couple other things, right? We're going to want size is empty, and the reason we need that, in fact, if you hover over here at the very top, I've got a bug here. It's saying like, well, hold on. Class ArrayStack must either be declared abstract or implement abstract method is empty in stack. I don't know what line 3. So what this is telling me is if I go to the stack interface, I've got push, pop, peak, is empty, and size. If I'm writing the code for something that I'm saying is a stack, and that's what I'm basically asserting here by saying, well, this is implementing a stack, I must implement all of the methods described in here. And I've implemented push, pop, peak is empty. Or no, push, pop, and peak, but I haven't implemented is empty, and I haven't implemented size. So that's why it's yelling at me, because I haven't written it all. So I better go along, and so I've got my constructors, push, expand capacity, pop, and peak. Great. So, oh, and that's this warning here is basically saying, in fact, I think I updated this. If I refresh this, yeah, there's a little bit more detail here, just so. When you start implementing an interface, you may see your IDE telling you there's an error. This is to be expected. So here's a typo. Someone can make a PR for this if you want to fix the course website, or at least an issue. This is to be expected since you are saying that you are implementing an interface, implementing the interface. Java is expecting you to implement all abstract methods from the interface. This error will go away once all abstract methods are implemented. Okay. Well, we're just carry on implementing everything, and hopefully once we finish our is empty and size, that warning will go away. So where did we leave off? Okay, size and is empty. Okay, well, size, all we got to do is return the top. If you remember, because the zero-based indexing, top always keeps track of the next available spot. So if there are 5 things in the stack, top will be 5, but indices 0, 1, 2, 3, and 4 will have things in it. But that's 5 things, right? Because we count the 0. So let's go and write our size. Public size. Oh, public int size. And all we do here is return top. That's all we got to do. I can get fancy and say this dot top just so it's really obvious that it's, the field from this instance of the stack. You'll notice though, like if I delete this, IntelliJ is kind of smart enough. If I just start typing size and I hit tab, it's just going to be like, oh, okay, well, I'll just start filling it in for you. And here, okay, it's returning 0. That's obviously not what we want. We want to return top. But that's it. Great. So now we've got our size. And now the only one left is empty. So is empty, tab. So by default, it's just saying like, okay, return false. But IntelliJ doesn't know what is empty should be for the class we're writing. So it just fills it in so like it just stops whining. So is empty. Well, when is our stack empty? Well, when there's nothing in it. So what should size be when the stack is empty? Well, it should be 0. So top 0. Okay, so we'll just return if top equals 0. If top is equal to 0, this is true. Then this method returns true. If top is not 0, well, then this gets evaluated to false. Because remember, this is an expression. A lot of people sometimes forget that this right here, sure, it's a question, but the question, like, gives us an answer, true or false. Like, this right here is an expression similar to 1 plus 1. 1 plus 1 results in 2. Top equals 0 will result in either true or false. So we return whatever the evaluation of this expression here is. Cool. Just double check I'm recording. Yes, I am. So there. Now we've got our size and our is empty. If I go here, look, now it's not even complaining anymore. There's no bugs. We've got a couple warnings. What are the warnings? Class is never used. It's never used. Manual array copy. Yeah, that's just, I like that. If you ever see this warning in IntelliJ, it's letting you know, like, hey, you know, you're doing this manual array copy. And if you click it, there, we can do this. And it's just like a tighter version of expand capacity. But for our purposes, I like this because to a new programmer, like there's no magic here. Where if I go back to, if I go back to this, you're seeing system array copy, and you're gonna think, wait, what is that? How do I? This, it assumes that you don't know about system.array copy, right? It's just, oh, you're a for loop and you're iterating over everything in those two arrays, you know, and copying this, putting it into that. So it's a little bit more explicit. The code is very self-explanatory here. The other code is too as well, but I like it this way. If you write it this way in your assignments, that's fine. I don't care. If you write it this way in your assignments, that's fine. I don't care. They're the same, right? It's just, yeah. So if false and top equals 0, so is false and top equals 0 the same? Well, I'm not sure I understand the question. If top is 0, that's true, right? So top equals 0 is true if top is 0, and that means it's empty. I could ask, like, is not empty? And if that's the case, I would have to do something like that, right? But is your question answered? Okay, cool. All right. Sounds like you got it. Okay, great. So now we have our stack. Cool. So size is empty. Notice how, because of zero-based indexing, top tells us the next available spot and the number of things in the stack. Cool. All right. Now a toString. We always like to have two strings. Realistically, we also like to have an equals as well and a hash code. But those are a little advanced right now, so we're not going to spend time talking about them. Although I think if you download from the course website the ArrayStack code, let's have a look here. Yeah, if you download it, I'll have like this fancy equals and fancy hash code just for completeness. And feel free to have a look at these and see if you can make sense of what's going on. But the toString is what we're going to focus on right now. Ooh, don't need that. Okay. Now, you'll notice that, like, well, hold on. You're saying that if we're implementing everything here, so we're saying ArrayStack implements stack. If I go look at the stack, stack only has push, pop, peek, is empty, and size. It doesn't say toString. And you're right. But we're not required to only have those things. We can have additional things. And writing toStrings for all our objects that could get instantiated is a pretty good thing to do. We like to have our toStrings because if I've built a stack and I'm like, okay, so like, what does this look like? Like, let's go back to lecture 1 where my main is. I'm gonna go here and just say, okay, I'm gonna build a stack of integers. My stack equals a new array stack. And whatever, I won't put anything in there. Great. One thing I want to emphasize too here before I carry on is notice that the type of the reference variable is stack, but the actual thing that we're creating is an array stack. But array stack is still a stack because we've ensured that, because we're saying array stack implements stack. So if I ever come along and build something called, I don't know, maybe something called a linked stack, that is also a stack that we're totally going to learn about very soon. I should, if a linked stack is also a stack, eventually I should be able to do this. Linked stack, and this will all still be entirely fine as long as my stack is a reference to something that is a stack. But more on this later. I'm just giving you a neat little heads up. If that confuses you, sit tight. We'll get there in like later this week. So I'm making an array stack, and I know I can push things on my stack. So my stack.push. Assuming everything's working right, let's push like 11, 12, 13. Actually, no, I like to do like 22, 33, 44, and then 55. And of course, remember, I'm not actually writing element here. This is just IntelliJ being like, oh, push takes something of type T. In our case, that T is a stand-in for integer, and it's called element. So if I go here, that's why this is like, oh, it's called element. You're giving it something called element. IntelliJ is just being nice. So now I have a stack, and I should be able to say sout my stack dot is empty should be false. Here, actually, let's just go here. My stack is empty should start at true. And then I'll also ask size, which should be 0. And then after all this, 1, 2, 3, 4, 5. If I run all this, and then I say this again, now is empty should be false and size should be 5. 1, 2, 3, 4, 5. If everything's working correctly. So I'm going to run this real quick just to see what we get. There, true, 0, false, 5. Good. Because new stack. Is it empty? Yes. Makes sense. What's its size? 0. Makes sense. We push 5 things. Is empty? False. Yeah, because there's stuff on it. And size, well, it's 5. Let's do another quick thing here where I do like my stack.pop. My stack.pop. Pop 2 things off. Note that this actually, pop returns something, pardon me, of type T, but I'm not actually doing anything with it. What I mean is I'm not saying something like int a equals. If I cared about getting whatever was there, I can do this, but for my purposes right now, I don't care. So basically the pops are just removing 2 things. So if it was 5 and then I remove 2 things, well, 5 minus 2 is 3. So I should hit run. I should see at the very end now a false 3. False 3. Good. So let's make sure that makes sense. New stack. It's empty. Size is 0. Nothing's there. We push 1, 2, 3, 4, 5 things on it. Great. Is it empty? Well, no. That's this right here. Because there's 5 things there. And well, what's its size? Well, it's 5. And then we pop 2 things. This is removing 2 things. So if we remove 1 thing, well, that's 5 minus 1. That's 4. Remove another thing. That's 3. And a stack with 3 things in it. Is it empty? No, that's false. And what's its size? Well, 3. Any questions about what I just did here real quick? Okay, if you have one, throw it in the chat. I'll listen for the boops. But now the problem is, I want to say, okay, my stack. Let's print out my stack. And if I do that, sadly, I just see ArrayStack at 1B28CDFA. And that's not very handy. I want to be able to see something that kind of like gives me information about what this stack looks like. And for collections, they're all going to like our, where was it? Like our course list or contact list. So here's our toString. I'm going to basically just copy this because it's going to look very similar. And then I'm going to go to my ArrayStack, go down here, and I'm going to just paste this in here. Now, it's not going to work out of the box because I've got size and friends, which doesn't make sense. But in our case, it's top, because top keeps track of like, okay, we want a for loop from 0 to top. And then I don't want friends, because friends isn't a field from this class like it was in the contact list. Contact list had size and friends. Close this, close this. Here we have stack and top. So it's not friends, it's stack. So I'll just go through each thing in the stack, ask what its string is, because you know what's kind of cool? Is everything in Java, like this is a generic thing. We're writing this, it's generic, it's type T. And everything of type T must be an object. What I mean by that is, if I go here, you'll notice that when I created the stack, it's of integer, not this. If I do this, it's not going to work. Type argument cannot be a primitive type. You can't do this. You cannot use primitive types in our generics. So the solution to this is, well, Java has an object version of everything that's a primitive type. So int, well, there's integer. Double, well, there's double. Character, char, well, there's character. They're all the object version. You can kind of like swap between the two when just using them in your code to check the quality and assignments and whatnot. But for our cases, for generics, the solution is just use the object version of integer. And now I heard a boop, but just one second. The benefit of this is if I go to integer, I mean here, this is the integer class. This is the code for an integer. Okay, there's a lot of stuff going on here, but if I do a control F, I will find a toString. So here's my toString for my integer. I mean, it's complicated, so we don't need to go in there. But the point is, in this class, in the integer class, there's a method toString that exists for integers. Meaning, when I come along here in my ArrayStack and say stack at index I, well, stack at index I, it's an integer. And I know that that has a toString. Even if it didn't have a toString, it has one because it gets one for free from object. The one it gets for free, if we go here, is this, right? It's not very helpful, but it exists. So the point here is, because everything that's generic, anything of type T must be an object, I know I can ask that thing to give me a string representation of itself, which is pretty cool. So I start with an empty string. I'm going to loop through all the things there and say s equals s plus stack at index I, which is an integer, get the string version of that integer, and then add a new line here. Well, I probably don't want a new line. I'm just going to add like a comma space. And then before anything, I'm going to say s equals s plus, I'm going to do something like this. Top. There. So I'm going to basically go through and just create a string where I just tack on all of the, oh, I got something in my eye, all of the integers in the stack. And then at the very end, I'm going to add like an indicator that says, okay, this is the top of the stack. We don't need this, but I'm just going to have it there because it helps us know which end's the top. And then return s. So if this worked correctly, and I go back to lecture 1, when I go to print out my stack, it should now automatically call this, which is overriding the one from object, which you can see if I hover over here. So now it won't use the one from object, which is just this ArrayStack at 1B28CDFA. Now it should call this one that I wrote right here. So I should expect to see 11, 12, 33, and then that arrow to top. So I'm going to hit run, run. I'm going to cross my fingers. Look at that. Isn't this a much more helpful version of a printed out stack? Where before it was ArrayStack at blah, 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 blah. Well, now I look at this and go, oh, okay, that's my stack, and it's got 11, 12, and 33, and I know the top is the 33. Cool. You know, again, we don't need to have that top there. Like, in fact, I'll comment this out for a second and I'll rerun. So there, I see this if I don't have the top, which is fine. But then you might be thinking to yourself, wait, which end is the top? Is the 11 the top or the 33 the top? I don't know. Well, to eliminate any ambiguity, let's throw that on just so we now know, oh, it's there. And if you ever think like, oh, I don't like having that, you know, leading comma there. Okay, fine. You can go here and throw something like this. If I is less than top minus 1, oops, I'll take this, copy, paste, and just that, and then don't include that there. So if I is not the last thing, also append the comma space. If it is the last thing, well then we won't append the comma space. So now if I go back and run, we shouldn't see that last comma. There we go. Oh no, but I should have a space. Okay, the solution to this is there. Add the space so we see a nice space after that 33. Rerun. 11, 22, 33. Cool. All right, I heard a bunch of boops. So, okay. Why is int primitive and integer not? My bad, never mind. Are int and integer interchangeable? Interchangeable, haha. They are in a lot of cases where you're using them, but like not if you're saying like, okay, this is something of type integer where it needs to be an object. But for example, if I go back to lecture 1, I'm popping. The things on this stack are type integer, but if I come along and say int a equals, int b equals, and then I say s out a, oh, and then s out b, I can take, like, pop is going to return an integer here, but I can put that integer into int a. And if I print these out, I should see the 55 and then 44. Run. Yeah, 55, 44. So they're interchangeable in a bunch of places, but not necessarily all the places. Good questions, though. So there we go. Cool. Okay, so let's go back to checking out the lecture content. So we've got our is empty, then we've got our toString. Now this toString here looks a little different than the toString than the one I wrote here. This one is basically, like, this is doing, like, creating a string and then appending to the string. But if you remember, strings are immutable, meaning once a string exists, you can't actually change what that string object is. So that means that, like, when I say s equals this empty string, okay, and then I see s equals s plus this, what it's ending up doing is it's not actually taking s and then changing s to include this part. It's taking s, appending a new string to it to create a whole new string, and then storing it in s. So this is actually going to go through and create a whole bunch of new string objects, which might have a lot of overhead for your computer. So an alternative is to use something called the string builder, which is mutable. You can change it, but then once you're done, you say, okay, toString, and then it only ends up actually creating one string. So it's a way to kind of save resources for your computer. Are you recording? Yes, I am. Thanks for asking. So if you're looking at this thing like, whoa, what? Look, it's actually, if anything, you might even find it simpler. Create a new string builder object, new string builder, put nothing in there. I think you could also put an empty string in there. It's not going to make a difference. Your for loop. And then builder, append to it, stack at index I. Then append to that, comma. And then once you're done that loop, builder, append that top thing. And then once you're done, return the string thing of the builder. And it's cool, right? Like the builder object actually has a toString itself, which is neat. Every object has a toString. And again, if you wanted to do that thing where you don't want the comma on the last, just add an if statement, that's all. What is the conference guest? Oh, don't DM that to each other. I don't want that on YouTube. All right, toString. Okay, for next time, download the stack and download ArrayStack. Check out the aside-on testing. Now, all of you have gone through lab 4, which is lab 3, which is about testing. And real quick here, if I go to here, I'm going to close this real quick. Nope. There we go. So here is ArrayStack, right? Let's make sure I'm on the right one. Yeah. So here's ArrayStack. I'm just going to close all this. Close, close, close. ArrayStack test. Q. Index. Okay. ArrayStack test and ArrayStack thorough test. So I actually have 2 versions of the test. ArrayStack test is it's a simpler one. But if we go look at our ArrayStack, this is basically identical to what we just looked at plus these bits, and there's comments on certain things. Yeah, so we've got our toString. This one's using the string builder. We've got our equals. This is the fancy equals. There's an aside on how to do equals properly from a couple topics ago. All it does is check if the tops are the same and if the contents in the stack are the same. If they are, then they're equal. And then there's this hash code. There we go. Don't worry about these right now. If you really care, open up Google, say, what is the Java hash code? And you'll learn all about it. But not important for right now. And then here's our equals. In my ArrayStack, I wrote a bunch of tests. That's saying like, okay, a new stack starts empty. An empty stack has size 0. Is empty returns false when it is not empty. Pushing item updates the size of the stack. Pushing an item results in it being on the top. Pushing 6 items on stack expands capacity. A whole bunch of tests that are designed to be written to verify that the ArrayStack class that we wrote is correct. And if you've got a big project, like look at all these tests I have here, right? People are going to say like, well, why don't you just write the tests in your main? If you've got a big project, how many freaking tests are you going to have in your main method? No. You don't do that. You write your actual software that, you write your main method to be your main method. You write your tests in this nice place for unit testing. And it's important that your unit tests are very small and testing only these little compartments of your code. So I've got all these tests. In fact, I think I can like run all tests. I'm running all the tests on stuff related to this course. Oh, we got an angry child upstairs. So look at that, 274 tests pass. So I know everything's working properly. This is fantastic. Anyways, so we've got the tests. We know it's working good. Cool. Close project. And then lecture stuff. All right. Okay. And of course, you're all reading through the chapters and then code. If everything's done correctly, here's some other tests you could do here. You could throw this into your main for quick and dirty testing. But again, you're going to want unit tests realistically going forward. But this will do the trick if you're just looking to do a quick test. Lecture 1. I'm just going to go here, take this out, paste. Don't know why these are not indented, but uh-oh, no such element. Oh, I need to import that. Import, there. This has to be included. Java util no such element exception. Let's try that again. Uh-oh. No such element, what? Oh, yeah. This is what we expected. We wanted to see a no such, yeah. This is saying try to peek on an empty stack, catch the exception, which if you go look at peek, peek. If size is 0, throw a no such element, meaning you can't, there's nothing to get from an empty stack. Same with pop, right? So if it's empty, in fact, you can actually replace these here to is empty. Is empty, there. Now it might even be more readable to you. If it's empty, throw this exception. And this quick little test here is saying, okay, try to peek from an empty stack. I know it's size 0. And then catch the exception and then just print the exception print stack trace, which is just saying this. And it's cool too, right? It's saying like, okay, on lecture 1, line 59, right here, you called ArrayStack peak, and if I click on this, it'll take me to ArrayStack peak, line 48, that throws this exception. So it kind of tells you the stack trace. It tells you like where in the code and how it got to that method where something went wrong. Neat little information that you might care about. Yeah. Cool. There's the code. All right. Next topic. Links. All right. Before, though, we talk about links, do we have any questions? Let's check here real quick. I'm pretty sure the next lab, so lab 4, is stack stuff. So in lab 4, you're going to be playing with the stack. So you'll have some time to play with the stack. Lab 5, making link structures. Okay, so lab 5, you'll be working with link structures. But in the next lab, you'll have enough time to play with the stack stuff. I have so many questions, I don't know where to start. Do we write directly into stack.java file that we downloaded from lab 4? No, the stack.java is the interface. You're going to want to create a new class called ArrayStack that implements the interface, like this. You're basically, for the next lab, for lab 4, you're basically writing this class. I realize you can download it, but that kind of defeats the purpose of writing the class and getting the experience. Okay, yeah, cool. Okay, well, what are your questions? You have so many questions, you don't know where to start. Well, what do we got? What do we got? And I see Timon's mic is on. Oh, no. Okay, well, it looks like Timon was raising his hand, though. You're sorry. Oh, okay. No worries. All right, well, if you have questions, throw them in the chat. A lot of tests seem dumb. Can you explain why tests are so important and why even the dumb ones are needed? They're not dumb. Here's why they're not dumb. Okay, close project. I'm going to open up the other one here. ArrayStack test. You're going to look at this and you're going to think to yourself, yeah, this is stupid. Why would I do this? Obviously, an ArrayStack that's created is empty. Why do you even need to check that? Hold on. You're making a big assumption there. ArrayStack starts empty, so it'd be that. Does it? Confirm that it does. So create an ArrayStack and assert that it's empty. If it's not, imagine running this. So, for example, I've seen students make this bug. When they start writing their constructors, for some reason, every once in a while, they might accidentally come along and do something like this. Okay? Where they accidentally, maybe they type in the wrong value there. And if you show up and you're thinking, oh, well, obviously a new ArrayStack is empty. Why would I ever want to test that it's empty? Obviously it is. I know it is. Well, prove it. I'm running this test. Uh-oh. A new stack starts empty. I assumed it did, but it's not. So now I know, uh-oh, I got a problem here. Well, obviously this one's easy to fix because I just did it. But the stacks help you find the bugs. And the tests help you find the bugs. And it's not just about the tests. Obviously the tests are important, okay? But when you start writing these unit tests, you are writing test to test very simple, specific functionality. And when you do that, the exercise of writing the tests and thinking about the tests helps you debug already. You don't even need to write the full test. You're going to think, okay, I need a test to check this. Uh-oh, I don't have any logic in that in my class. I need to go write. So the whole process of writing tests and being very deliberate about thinking about your code helps ensure correctness, not just by the tests confirming correctness, but by getting you to think about this stuff. Okay, how do we know? Okay, a lot of terms, okay. They're not, they say, oh, Okay, why do we need an interface instead of a class? What is the main difference and what makes an interface important? We're going to hit that question as soon as we get to... I can explain to you what I said before, but it kind of is hard to see the motivation of an interface until you see an example of, oh, that's why it works. So, you know what? I can show you real quick here. Imagine for a second, let's close this project. Lecture stuff. Okay, course test, lecture 1, stack, class, ArrayStack. Okay. You're looking at all this code here. And it's a stack. My stack is a stack. But it's made in ArrayStack. But because I know ArrayStack implements the interface. Remember, the interface doesn't actually have any code in it other than saying what's there. I'm hearing a lot of boops. I just want to make sure. Okay, there's a lot of back and forth. Let's make sure it's on topic when we get there. But because I know ArrayStack implements the interface, I can guarantee it's a stack. So Java is comfortable saying, yeah, okay, so this is a stack. ArrayStack, yeah, it's a stack. If I go into ArrayStack and get rid of this part, it's going to say, no, you can't. It's going to be mad. It's going to be like, well, okay, you can't, like, no. I can't guarantee this is a stack. This is an array stack. I can just fix this by doing this. Okay, great, fine, yeah. Now, it's an array stack. It's going to work just fine. If I run this, everything should work just fine. Right? Uh-oh, does not override super. Oh, it's because it's saying override, but that's not important right now. Great. So what's the value of saying it implements interface? Well, if I can guarantee that this is a stack, if I know this is a stack, then Java is comfortable. If Java knows it's a stack, Java is comfortable saying, yeah, this is a stack. And if it's a stack, I can do what? Well, I can do push, pop, peek, is empty, and size. If I come along and I write my linked stack, which is coming up, I should be able to come along and say this. And if linked stack implements the stack interface, then I know linked stack is a stack. I can guarantee, Java can guarantee it's a stack, because when you say something implements stack, you have to write all those methods. So if Java's like, yeah, okay, yep, it's a stack because I know it implemented it. Obviously, this is saying like, well, I don't have link stack yet because we haven't written it, and we will. But if this knows it's a stack, I should be able to change out what the actual implementation is. If I hit run on this, it works. If link stack was implemented and I do this, boom, I hit run, this should all work just fine because it's still a stack. Which is awesome because now, by changing one little thing right here, I'm completely changing out the back end stack stuff that my program's using with changing one part of one line of code, which is pretty cool. If that hasn't satisfied if that hasn't satisfied you in terms of answering your question, once we actually implement the linked stack, this will probably become a little clearer to you. Interfaces is not something natural, I think, for a lot of people when they start, but once you kind of see it used, it'll click. Remember, Java wasn't made for you to learn programming. It was made by engineers for engineers to do the things that they knew they wanted to do. All right, why do we need interface? How to make sure each method is working, eh? Should you write tests as you write your code? Timon? Absolutely. If it's testable, yeah, that's a great idea. I mean, while writing or after. Some people will write the whole thing and then write the test. Some people will write one method, then write the test for the method to make sure that method works before you go on, before you go on to start writing more methods that might use that method. That's a good strategy. Some people even go write the tests before they write any of their methods because they know what they expect their class to do without doing it. In fact, look, if we go back to close 102 ArrayStack test. Look, all this stuff. It's a stack, but I'm making an array stack. All of these tests, there's one example. There's one test in here, this one, that is actually specific to an array stack because we checked the expand capacity. All of these other tests need to pass if this was a different type, if this was a linked stack. This right here is basically testing stack. So I don't even need the actual implementation to know what I need to test. So yeah, some people will actually write the tests before they even write any of the methods. Just do whatever works for you. Okay, let's keep going. I saw more questions. I mean, well, you're writing both. So is this like debugger or PyCharm? No, because there is a debugger in Java. I can go here and say debug. And then my program will halt at line 18 and be like, okay, well, you've got a stack, and here's your stack. Stack is, you know, a bunch of not showing null elements. Okay. It's got at index 0, I've got 0. There's nothing there, and the top is 1. This makes sense. And I can do like step, step, step. And then I see my stack. It's growing. So there is a debugger. Is ArrayStack Java a generic stack? ArrayStack.java. Well, the ArrayStack that we wrote, yeah, it's generic. But Davin's saying no. I'm not sure. Wait. Oh, you mean the one, like, why couldn't you import it somehow? You mean the one that already like, do you mean like one that already exists in Java? Because you might be asking, yeah, okay, so you might be asking, why would I, like, why not just import the collections that Java already has? Well, realistically, in the future, that's what you're going to do. But we're writing them to know how they work, right? It's kind of like saying, like, well, why wouldn't I just use the list from Python? Yeah, but we're learning how that works, right? So you're saying, like, imagine signing up to learn how to drive a car. Or sorry, imagine signing up to learn how to build a car. And then someone in the class is like, well, why don't I just buy a car and use it? You're like, well, yeah, but we're here to learn how to build it, right? So it's kind of like that. Okay, because I'm quite confused right now. This is all brand new. Which part specifically? Oh, the interface stuff. Yeah, it'll come together. So if we write a test class, can I just constantly import my tests from other projects and use them for everything? Yeah, you totally could, where it's like relevant and appropriate. Yeah. How is expand capacity different for stacks? I'm not sure what you mean. Do you mean like for different types of stacks? Because with a linked stack, we don't need expand capacity. And we'll see why. But with an array, arrays have a fixed size, right? So we need expand capacity. But other types of stacks might not need an expand capacity. Arrays and stacks. Well, the stack that we built, the array stack, because it used arrays, we needed the expand capacity. If you're wondering, like, well, how is it different between like course list and array stack? Like here's this expand capacity for array stack and course list. Here's the expand capacity. They're not. They're basically the same, right? Create a new array that's twice as big. Create a new array that's twice as big. Go through each and copy over the contents. Go through each and copy over the contents. And then assign the thing to the new version. Assign the field to whatever the new one's called. Assign the field to whatever the new one's called. They're the same. This expand capacity is going to be nearly identical every time we write one. Cool. Did that actually answer your question though? Okay, cool. All right, now links. Okay, links. I realize we're almost out of time, but I can introduce the idea here. Warning. And the reason I'm adding this warning is because even I was confused when I first started learning this stuff. At this point, we are not defining a new abstract data type. I'm not defining a linked abstract data type, right? Remember, our abstract data types are our stacks, our queues, our bags, our lists, our trees, our graphs. Right now, I'm just creating this new idea that we will then use to go and implement ADTs like a stack. So we'll make a linked stack, like we wrote the array stack. But links in and of itself is not anything other than what I'm showing, what I'm about to show you. So don't start thinking, oh, here's a new collection. No. This is just kind of talking about links is analogous to talking about arrays. Okay? So, links. Arrays have a fixed size, right? But that's not a big deal because we can change the capacity. Kind of, right? Like we're not really changing the capacity. We just make a new one, copy it over, and pretended we changed the capacity. When using an array, we may have to shift things around when adding and removing too, right? So here's some notes about arrays. Arrays have a fixed size, and when using an array, you might have to move things, right? Like if I have an array of 10 things and I want to remove the thing in the middle, there's a good chance I might want to have to like move some stuff around to fill that gap. And traditionally speaking, arrays have contiguous memory. That's not really correct, but classically speaking and conceptually speaking, they do, right? If I go to memory address 9FB27, and that's the beginning of my array, the next memory address is 9FB28, 9FB29, 9FB2A, and so on will be part of that array, classically speaking. Now we're going to have something called linked structures instead. And a linked structure is one that consists of objects, a very simple object. A lot of time we call these objects nodes, that just contain some information and then a reference to its subsequent node, the successor. So like in an array where you have index 0, 1, 2, 3, what comes after index 0? Well, the successor is index 1. In a node, its successor is like, well, the next thing. So this is the idea. We'll have nodes, we'll have one head node, and each node will reference a subsequent one. So that's where we'll leave it today. But yeah, this is where we're going to pick up tomorrow, I guess, the linked structures. Any last questions before wrapping up? Okay, seeing nothing, I'll stop the recording and I will see you all later. Okay, cool. See ya. DC or Marvel? Movies, Marvel. Characters, DC.